Okay, so next step. So there are there are certain other things like it's possible that one postman is very slow and the supervisor is very angry with him. So he said, "No, I don't like you. So let me go and I won't disturb him, but I want the map to be complete because the map, the whole operation will be complete until all the map tasks are complete. So if one postman is taking a lot of time, even though rest 99% is done, everyone is waiting for that map task to complete so that the job is complete. Hence, the master decides, okay, this guy is taking too much time. Let me assign this split to some other map task. So if that map task finishes faster, then he will take that output and finishes the job. When the job is finished, he kills the the postman, or he kills the worker that is processing slowly. So whichever map or whichever worker finishes the output faster, the master takes that output and kills the other one. So that is sometimes okay. That is also done sometimes. It is called as speculative execution. We will discuss that sometime later too. Is it clear? Sometimes map task fails and you submit the same job again. So what this slide is saying, that if you submit the same job again, we have to make sure that there is no relation between these two runs in the system at any point of time. So when you say the semantics in the presence of failures, the way that the jobs are named, the way that the tasks are named, the way that they're stored is different for each run. Hence, there is no clash. So locality, we said, we'll discuss this again. We want to basically say that the job has to happen on the split, and the split has to happen in a worker. And it so happens that we want to make sure the worker and the split are in the same machine, right? That is called locality. So the worker which is doing the compute and the split which is the data has to be on the same machine. As I said, the splits are in the distributed file system. Even if they are in the same machine, if they are not in the same machine, the map task can fetch the data from some other machine and complete the map task. But it is more efficient if the map task can execute on the same node where the data is also present. This is called locality. And we also discussed that instead of moving the data, move the program to the place where data is. This is what that means. So we are taking a simple 15 lines of MapReduce program from a developer and running that 15 lines of program in distributed fashion for searching 20 billion documents to get the count of 20 million words across the web. And in this case, we are also saying that there is a locality where every worker which is running, it is expected that the split is stored in the same machine that worker is working in the distributed file system. So Hadoop takes care of that for you. You don't have to worry. Okay, is it clear? Now, if there is only one copy of the split, what happens if that particular machine fails? So that's why in the distributed file system, it makes typically 3 copies. So when we discuss the Hadoop cluster topology, we will tell you how and where and why these 3 copies have been stored in the distributed system, what is the rationale behind it. So you will see that even if 2 machines fail, there is still 1 copy left, and the data can be processed without interruption. That's why Google File System, in this case, distributed file system, recommends 3 copies of the same split within the file system. So that is how the redundancy, or that is how the recovery from failures can be done. So we'll switch this when we discuss the cluster. We will discuss this again. So again, this is more like redundant execution. Okay, the slow task can be executed. So task granularity and pipelining. So as somebody asked the question whether the map and reduce operations can happen parallelly. You see that the reduce operations are started before some of the maps are completed. Okay, so that's what this is. This particular slide is trying to do. So you can again, this is more like a one sec. Okay, all right, guys. So I think I have posted these slides and the map reduce Google paper to the web. So I should ask your coordinator to get those 2 documents. Again, I would suggest you read the Google paper. Don't focus too much on slides because there are better slides coming. Okay, because I teach the same set of slides to IIIT students. So I teach it in this detail, but it's not required. Right. So I would suggest that to get a good overview, read the map reduce paper. Right. Don't try to do too much onto the slides. If you're okay, you can also look at the slides. I don't have any issue. But we will go through this one more time. So in subsequent classes, you will see that you will run some map reduce operations. You will do some. We'll also show you how to run the map reduce task, how all those things are done. So I will suggest each of you buy a laptop. If you don't have a laptop or a desktop, we will tell you how to install Hadoop in some subsequent classes. You should be able to run some of the examples. Okay. So in a typical cluster, you can see here, they have hundreds, thousands of CPUs, right? In Google, in Yahoo also, they have about 25,000 CPUs total and 2,000 to 3,000 nodes each. Okay, that's what this is. Again, we will, when we discuss the cluster, we will see all this. grep, this is how they've used, and then sorting. So this may be little, I will cover this piece in the next class. Okay, last few slides I'll cover in the next class, and then we'll move on. Okay, guys, thanks. If you have any questions, please. Yes.
This is Ashok.
Yeah, sure.
I'd like to let these guys to know, maybe they are wondering why we are covering MapReduce this much, because they are attending for a Hadoop administrator course, and they might be wondering. So
are you guys still wondering, or you have an answer already? Hello? 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 Guys, I cannot hear you. What is that?
Hello?
Yeah. Are you guys still wondering why we're covering MapReduce? Okay.
Great.
Ashok, go ahead.
Yeah. That's what I would like to know from you, because Hadoop administration is not like a traditional Veritas cluster administration or something like that. So here, developers will not be entertained to run their code directly on the cluster. So developers will be restricted to the standalone mode only. So all those scripts which were written by the developers will be given to the administrators, and administrators will schedule the jobs. So in order to schedule those jobs, you have to have a little bit understanding of how MapReduce jobs will be executed. So what we are trying to cover here is we are also giving you the internals of a MapReduce program. So if someone is feeling comfortable, they can do development as well. So it's not mandatory that you should get all these MapReduce things in depth. So if you are getting it, then it's going to be a bonus for you. If you are not getting, you are just least bothered about it. So in the coming classes, we will let you know how to execute MapReduce jobs, because that's going to be your job responsibility. And this understanding of Hadoop cluster and Hadoop distributed file system, I'll cover in the coming classes, like when Redisar is not going to available, 4 to 5 days of schedule he is having outside. So in those days, I will cover those concepts in depth.
Okay, folks, that's all for today. And if you do have some questions, please send us an email. We'll be happy to answer. Okay. Thanks.
How to
Thanks.
get this
Bye.
document?
Yeah, yeah.
What is that?
Excuse
Yes.
me.
The documents, the slides and the paper, and where do we get this information?
So
Yeah,
just
yeah,
contact the.
Karthik?
Yeah, sir.
Yeah.
Sir, I will take this card.
Yeah.
So we will send all these documents through your mail IDs. Okay.
Okay.
So
Okay.
it will take another day. So we are creating a repository. If that doesn't work, then we will send them individually, or else we will store all those documents in a Dropbox folder and we will send you the links.
Okay. Thank you very much.
Welcome. Anything else? Shreya, you are trying to say something, right?
Yeah, I was also planning to ask the same thing. Thank you.
Okay.
Okay, guys. Thanks. Bye.
Thank you.
Bye, everyone.
Yeah, hi everyone.
Thank you. Bye.